platforms. And then at SpaceX, I've been part of teams that worked on interfaces for rocket engine tests, the mission control for Falcon and Dragon, the mission control for Starship, and even got to work on some components that fly on the Dragon capsule. So I've seen interfaces in LabVIEW literally from K to rocket science. And I've picked up a couple of common themes. So a lot of times when we think of a UI for a complex system, we think of the UI as just abstracting out the controller or the DAC system or that, but it's really, the UI is really meant to abstract the entire system. And it's, in the end, the deliverable is not the data, it's not the, the individual bits, it's about telling a story. It's about, when I did my wafer test, wafer 7 failed because of this problem. Or, yes, this engine is good enough to fly on a rocket. Or, yes, this medical device is good enough to, use on a patient. So you have to make a UI that can tell that story. Now, we're engineers, so of course that story is going to cite its sources and back everything up with data. But in the end, it has to tell that story. When we're first prototyping, you just throw a bunch of stuff on a diagram, you put it together, you might end up with something like this. And that's fine. We've all seen worse UIs than this. And to be fair, I'm intentionally sandbagging a little bit. I use classic. So, let's give it a modern look, update it a little bit. So there we go. We got our super modern look. All right. So here's the same UI, just a little bit cleaned up. And this is a fine UI. We've all seen UIs like this that companies have built their entire test infrastructure on. But looking at this VI, can anyone tell me what it's doing? Can anyone tell me a story about what's going on here? Yeah, squiggly lines. And so the first time you sit down at an interface like this, someone has to train you on it. And so they might say things like, oh, you just have to remember that, after each test, remember to set 0.5 back to 0. Or, later when you're watching it, you're like, the 3.1 seems low. Like, I'm going to have to ask Janet and R&D if that's an okay number. Or like, is this noise normal? And so you're asking all these questions because you don't have any of that context. Anytime you're looking at a UI and you ask a question and someone does this, okay, so a little background here. How many of you have had that moment? How many of you have been the one to give that background? And every single part of that UI has to have this entire backstory in order to know what's going on. And sometimes you get that backstory if you ask for it. And other times it just kind of fades into the background and the operator knows I set 0.5 to 0 and then I hit run, and that's all they know about the system. And so when something goes wrong or if something's slightly off nominal, or if it's something they should notice that's going slightly wrong, they won't. They don't have enough context to know that. And so you end up in a situation where you really have no idea what's going on. And you're just, they're just numbers on a page, they're squiggles. You could look at an Excel spreadsheet of raw bits and it's about as useful. So how are we going to make a UI that actually tells a story, that gives us, a compelling narrative about our system? So step one is always to anchor your model. Talk to your operators, watch your operators in situ, run a test yourself. I know I've been guilty of this, of working on a system for hundreds of hours and then never ever actually using it. I always used it with simulated hardware with that one DAC card, and then you hand it over to your users and they do everything, and you never actually see it in the full context. One time I had a user, I decided to go sit with my users and watch them operate a user interface, and they loaded a sequence, and when it loaded, it had a red X, and I was like, oh, that's weird. Why didn't the sequence load? And they're like, oh, when it loads successfully, it shows a red X, and when it fails, it shows a green check mark. And it's like, that's a Boolean inversion. I can fix that in like 4 seconds. But they were so used to it, they got used to that backwards story, and that became part of the tribal knowledge narrative of like, oh, you just got to know it. And so I did fix it and got a few questions the next week when people were like, why do I keep getting green check marks? But if you don't spend your time with your users, if you don't watch them, if you don't do it in their environment, you're not going to learn that. Yesterday, I heard a lot of stories about, well, in this case, the users are wearing 2 gloves, or in this case, they're in a really bright room or a dark room, and so a lot of those details that you can sit down with your user, you can have a Zoom call with them, you can talk to them on the phone, and they don't know to ask for those things or to tell you those things. And so sometimes it's relevant of like, is the test article on the left of the screen or the right of the screen? And so those little details, and so you definitely have to do that before you do any of the rest of the stuff we're going to talk about. You have to anchor your model and make sure you have all the data. So first, let's talk about context. Context is pretty important. So here's the first step of UI information theory. We're going to take raw data, just numbers. We're going to give it some context, and now we have information. Now I have something I can report back. Now I have some kind of quality. So let's talk about the different types of context that you can add for a system. So first of all, just kind of simple and numeric context. You definitely have to have just good, simple names. I've seen a lot of very mature systems that have a lot of AI1 space 2 indicators that were just thrown on and never given that name, or just generic names. They have AI1, AI2, AI3, and that little bit of work to just go in and give them nice, readable, logical, followable names is a big help. No naked numbers. I'm a big fan of sticking the units into the format string. I know that units are always tricky in any platform. I know a lot of people who will put the unit in the caption and put the caption next to the control. And there are other ways to do it, but that's an important piece of context. When you say, well, how hot is it? Oh, it's 7. And you're like, is that? I have no idea what that is. And I always like grabbing that degree sign. I probably have 2,000 searches in my history of ASCII table, and I'll pull that down, and I always got to grab it. Need something like in Excel where you can insert a symbol so you don't have to go hunt for it. Maybe I should memorize the Alt key. Embrace the metric system. So when you can put a control in that scientific method mode and it automatically does milliseconds, megawatts, kilopascals, that can be a great way to add context without having to do that consciously, without having to add the divide by 1,000 or whatever. And so, putting it into SI units, and of course that works really well when you use it alongside of that display format units. And so now you get milliseconds automatically, even though that number is actually, 0.00018. Thoughtful precision. I know we're all sometimes guilty of just leaving the default precision on, and I'll have the volume of a tank down to the 4th decimal in liters. I don't think that's doing a lot for me. I don't think I need that bit of context, and just chop off the numbers until it's useful. Now, sometimes you want to have that good feeling of just seeing the numbers wiggle. That reassures you that, yes, I in fact have data. And so sometimes I'll add that 1 decimal that wiggles a bit just so I'll see it, but you definitely don't need 4. And so you do have to take a little bit of time to go in and thoughtfully set that. And then finally, format things to be watched. You'll notice the first input voltage is doing the jitter where it starts to bounce around. And in certain cases, especially if you're going, you're changing orders of magnitude or going positive to negative, it can be very hard to watch. And so, don't hide those zeros. Use your fixed width. Think about your justification. If you have a number that's going to change orders of magnitude a lot and you want to left justify it, go ahead and pad it with spaces on the left so you can get that fixed width and have a very readable number that someone's eyes can follow without jumping around. So these are all easy to do. They take a little bit of time, but I think if everyone did at least just this, almost all the UIs would be better. And I know that a lot of you are doing most of these, and I know that I don't do all of these all the time, but it's always good to think about these. So the next one that I think is a lot less common is range context. When I found out that my motor's at 27 degrees or it's running at 27,000 RPMs, I have no context for that. And so that becomes something that your operators have to encode into their knowledge. They have to remember, oh, okay, in this case. And sometimes the engineer who designed that component and knows every aspect of it inside and out is the one operating the test. And then maybe they have all that context internally. But if they try to pass it off or they hand it off, or in the case that you have an operator who didn't design the whole thing from scratch, they only know to check the numbers that they look at. And so a couple of different ways you can give numbers range context is, one, showing movement. So that first example shows what we might call spark lines. It's just a simple chart. I don't have axes turned on, but it allows me to see movement. It allows me to see noise. It allows me to see, oh, that flatlined, or oh, that's wiggling a lot, or oh, that's going up. And so sometimes just that little bit of context of like, oh, I can see 4 of my channels are flat, or, let's say I have a bunch of thermocouples and I can see that a bunch of them are reading interesting and one of them is flatlined. now I know where to go start poking around. Another one is creating comparisons. So in this case, I'm using just a horizontal slider. And then because horizontal slider doesn't have the automatic range coloring built in, I've stacked that on top of an array of color boxes. And then you can color code different areas. And so in this case, we're going to say the white area is what we want. The darker areas are the bad. And then as it goes into those areas, you can even change the cursor to kind of give that visual clue. And so when I say, hey, which engine is not working right now, it's super easy to zero in on that. And not only the binary result of that, but that marginal thing. They're like, it's kind of borderline. It's getting close, but it's still fine. Like, we're still good for this test, but we should probably do some maintenance before we look at it again. It's important to define the range. So if we're thinking about the temperature of a human, you might say, okay, let's just start with some kind of range, 0 to 100. That's a Fahrenheit type range. They're like, well, sometimes people are hotter than 100, and no one's, if you're 15 degrees, then you have other issues. And so, okay, let's zoom in and say 92 to 105, which puts 98.6 kind of right there in the middle. And now we can have a little bit of context. If you have your high volume nursing station, now you can just make sure that number's in the middle the whole time. But of course, that doesn't have any quality to it. Is that a good temperature? Now, we all have that context memorized in our heads, but when you're talking about numbers that are less familiar, you have to give a little more context. And so, yeah, you can use colors to do that. That's one of the ways. Either using the sliders or the gauge. And then, yeah, that slider on the right that's showing different ranges. You might not want your screen to be red the whole time. You don't want to show, if red's your hazard color and your whole screen is lit up red. And so this is one that just changes the color of where the active region is. And so you can look at your screen, and if it's all green, you're good. And if it's yellow, warning. Now here's the bonus. That slider is a base LabVIEW slider, not a X control or Q control, and there's no property nodes. So see if you can figure out how I did that. And maybe we can do a 7 by 7 on that if anyone can figure that one out. That one took me a little while. Here's just another example of some of those comparisons. On that first one, I decided to go monochrome, so it fits well into a UI and doesn't kind of overwhelm you. But you can do a lot of different ways. You can show, good and bad regions. You can show optimal regions. And particularly if we look at that last slider 2C, I think that one tells the whole story. I start to have that piece of that story there. Like, well, yeah, motor 2C, it should be around, 26,000 RPM. If it gets up to 28.5K, like, that's fine. That's kind of optimal. But whatever you do, make sure it stays above 24K, because then the stuff gets bad. And like, I can tell you that whole story by looking at one little image. And now every operator who's looking at this user interface can give that context and can report those things and know when it's not bad enough that it's aborted the automated logic, but we should take a look at this, or it's looking suspicious. So here's an example of where I showed some motion. So this is from one of the old Waterloo Labs videos, where I've rigged up an electroocculogram that uses these silver chloride electrodes on your face that can measure the dipole potential. Your eye is basically polarized. The problem was, when I was testing this, I had to look away from the screen to test it. And so I'd have to look away from the screen, and I'd look back and I'd miss it. And so I added that XY graph and then store my own little history array and then tack that on as a tail so that you can really have an intuitive sense. Even looking at the green trace and the red trace, which are the X and Y axes respectively, it's not as intuitive or easy to follow and doesn't give as much context as that XY graph. Though later we figured out the trick because we use this to play Mario. Naturally, we hooked this up to an NES emulator so that using your eyeballs you could run Mario or jump by looking up. But yeah, later the trick we realized was rather than looking away from the screen, you keep your eyes on the screen and turn your head, which is still a relative eye movement, but that way you could keep your eye on Mario. Yeah, the pitfall literally was you jump over a pit, and in Mario it has the physics where you can kind of direct yourself in midair. And so you jump over the pit, and then you'd look back to the screen and it'd go right into the hole. All right, so we've talked about range context. Now let's think about physical context. So this is just kind of an idea board of a lot of different ways that you can put things in physical context. How does this relate to the physical hardware, to the actual system? Where are these measurements located? What is this data doing? Bonus points if you can name the context for all of these. One of my favorites is that top left that's from The Martian. That's when they're about to take off and the capsule's tilting, and it's a really intuitive way. You can see. I've of course covered it up with my my little arrow there, but you can, it's a really intuitive sense to see. Oh, the vehicle's leaning about this far, and I have some sense of how bad that is. Yeah, you also have Star Wars and Tesla and some of the more familiar SCADAs, and that one in the middle from the Matrix that I hate. That it seems to be showing you physical context, but doesn't quite sell it. But I do think about that UI a lot. So how do we add this physical context in LabVIEW? The first thing is you have to have eyes on hardware. No matter how good your data measurement system is, no matter how many channels you have, there's some things that you can't troubleshoot with data like you can with a camera. You can't tell the difference between the whole test stand blew up and your COM port is unplugged. A lot of times if you're looking at it. And so that, if the operator of the user interface is not physically has eyeballs on the device under test or the system or whatever they're controlling, especially if it has high energy or outputs or can do anything, even if it's going to vibrate that little motor with the flag and suddenly fall off the table, you got to put that camera on it. So, I work remote, and so I'll get Jim to set up a camera in our office, pointed at a little hardware setup, and that way, when I VPN in the morning and it's not connecting, I can go see, oh, okay, it's powered off and it's not my code. It's just that's powered off, and I can go remotely trigger my little CASA power supply to turn on my device. So yeah, definitely recommend getting eyes on hardware is really important. These are kind of organized left to right, easiest to hardest. So another easy one is diagram blocks. You don't have to be a whiz-bang graphical artist, but just throw some simple shapes down there, put some simple labels on it, and that gives you a lot of context. So now looking at this, I can say, okay, my pressure, my P1, after the pump, the pressure went up. That makes sense. And then it hits filter, and then suddenly the pressure drops to almost nothing. Like, I have a clogged filter. Whereas if you just showed that data without those simple blocks, you don't have that context to know what's going on. And so, that one's really easy to do and is a great way to give some context. Annotated models are great. When you can drag any PNG in, throw some numbers on it, and it just gives you that approximate context. So I can look at that motor and say, interesting, the top of the casing is getting a little hotter than the bottom. Even though I don't know the exact location, it doesn't need to be a super high fidelity model. It still gives me some context that's better than looking at it in a table. And that's better than, the naming can do alone. And so, rather than having, temp 3, it could say, top of case temperature sensor. And that's another way to get context. But yeah, annotating a model and putting it on is a great way to do it. And then the most involved is that interactive model. We've all seen this one, the shipping example. But, whether you're talking about a spacecraft's position in 3D space and you want to show that as a 3D picture control, or, have an actual instrumented model that, lights up in ways that give you information about it. But you also have to be careful that it's useful. A lot of the demos that I see that have these kinds of whiz-bang UIs, the utility of it starts to fade and the gee, that's neat takes over. All right, sequential context. So again, here's a lot of different examples of sequential context. Launch timelines, simple things like next and back buttons, the Domino's tracker. The one I like to think about is that Netflix, are you still there? A lot of times we don't think of that as sequential, but the more I thought about it, the more it's like, in Netflix's series of events, I'm going to show you a bunch of episodes, and then it does a check and says, am I still in the sequence? Are we still there? And so if you have a test system where the operator has to monitor it, and after the test is over, they need to go cycle some device, and they don't cycle it in time. Maybe an "Are you still there" can give you a lot of information. Can give your software information about your operator. Back to the Future was on last night. I actually watched it, and yeah, I love that one with the green, yellow, and red logs that they throw into the engine. The gauge and the smoke color, it tells a story. It tells you the sequence of events. It tells you what to expect next. It tells you, where you are, and it helps heighten the story. And so there's lots of different ways to do that. One of the simplest ways is just adding numbers. I've seen a lot of examples where, you gotta connect, you gotta set these 5 parameters, and then you gotta hit go. And users kept forgetting to hit parameter 4 and hitting go. And of course, there's more advanced ways to protect from that. But the easiest way that takes 4 seconds is just add some numbers on there. Users are pretty good at following these, and as long as you make them, nice and big and maybe a bright color, it makes it easy for them to follow the narrative, and it's really low effort. Using the installer pattern, where you're, next and back and maybe paging through a couple different screens can be great. It can be really friendly. It can also be frustrating for advanced users. I know, like, every time I install Git for Windows, you got to click through like 16 of those default settings. And so sometimes there are some trade-offs there, but that's a good pattern to use. Going back to that, you got to set all your parameters before you can hit, start. The more advanced option is to actually, disable that button until the conditions are right. But don't disable it and leave your users hanging. They have to make sure that they know, how they can resolve this situation. And so we think about this, and we've all seen this in web forms in particular, where if your phone number is not correct, or if your email doesn't have the right format, it'll yell at you. And so you could highlight that or put a tip strip in, so that when your operator says, why the heck can't I click start, that it's super intuitive and super easy. And over time, this trains your users. So new users can get trained through this, and by the time they're experienced, they can blaze through this really quickly. But when things change slightly, and actually now we have a 4th parameter, rather than having to go make sure and handhold every operator through it, I just add that logic, and now, oh, there's a new parameter, cool. And it trains them as you go, and even as you change things, they can get that. Kind of the highest effort and most advanced one would be, a config-based, user-driven sequence system, where, a user might define in a config, here's all my steps in my process, here's a nice description. You can even, it could even be actually setting certain parameters, and then, having a way in your UI where the users can scroll through that and get those prompts interactively, but putting it in their hands so that when they're like, actually, we need to add one more step, that the developer is not the one who has to go add that extra prompt or change that language a little bit. But, of course, building a config-based system and a UI to display all that can take a little bit of work. Does anyone recognize this sequence UI? We got a few. So I guess here's the hint. In the movie Star Wars: A New Hope, episode 4, originally in the script, the Death Star wasn't going to go blow up the Rebel base on Yavin 4. Originally it was just the rebels going to attack the Death Star, and it realized it's like, well, that kind of feels like terrorism if you're just going to attack them. And so they had to add some stakes, but they didn't have any of that in the movie. And so you'll notice if you go back and watch this, all of the context that says our rebel base is in imminent danger and we're going to be blown up is all done with off-screen dialogue and cuts to this UI. And then they just cut generically to all the rebel generals standing around going, but at no point does any of the characters say, like, yeah, the Death Star's coming. But that UI shows you where, it shows you spatially where things are. It shows you that timeline, getting closer. The red danger zone is getting closer to our green safe zone. And it tells a whole story and it heightens the context. And so, I love that. There's a great YouTube video that breaks all this down. If you're curious, I can share that with you later. Historical context. I like to think of, that high score leaderboard. And a lot of times, define normal. And so when you run your test, if right off the bat you get something that says, this is in the 99th percentile of test durations, or this is in the 51st percentile of temperature. And that gives you a lot of context so that your operator might know, this is an unusual one. I might flag this or add some extra reports that can help give that. And, you can do this live in your UI or you can do it in post-processing, but doing it live in the UI gives that context, while they're still doing the test, while they still have some opportunity to affect stuff. If they see, wow, this is the slowest test we've ever run, like maybe I didn't plug it in all the way. And so a lot of times that little piece of information that lets you check, against all of history gives you some context. The more advanced is, actually plotting it alongside everything. We would all love to have that UI that, shows you your current test alongside your last 10 or your last 50 or your last 1,000 tests, filterable. That is a challenging data problem. It's certainly not easy to do, but it can be incredibly valuable to understand the context of a signal, especially something that's changing dynamically over time or has like a very strict timing requirements or very strict tolerances. You can get a lot of information visually. And then, of course, as you reach a threshold where you now have tons of data, you can now start to use things like machine learning, where it can start to try to figure out the context from this. And of course, machine learning can figure out context that humans wouldn't necessarily connect just through the data correlations. All right, last one is familiarity context. Yesterday in Q's presentation, he talked a lot about leveraging a lot of the smartphone precedents. And you should definitely lean into that. Use your hamburger menus, use common icons. I love using the Noun Project. It's a website that has icons. Most of those require licensing and attribution. So sometimes I'll just go like, what does a server look like in an icon? And I'll Google server icon, or I'll go to Noun Project and Google server and just kind of lean into the crowd. It's dangerous to be too clever with your UI. If you're trying to do something really interesting and clever. I had a boss once who said, we don't allow clever programming here. And anytime you get too clever, it better come with a novel of backstory of, okay, a little bit of background on this. And so, yeah, if you can avoid being too clever and just lean into things that are familiar, then your operators will have, an easy time. They can sit down, at an interface and immediately know how to use it. Learning the lingo is important. Don't call it a DUT if they call it a unit under test. Don't call it a bulb if they call it a lamp. A lot of times the developer doesn't have all that context. And if you didn't go sit down with your operator and talk through the whole system and read their manuals or read those things, then you might call it the wrong thing. And that can add confusion when you don't call it the right name. And then virtual instrumentation, that was the whole principle of LabVIEW. And these are all actual LabVIEW controls. And I love using these. Sometimes it can be a little cheesy, but when you can make something that's immediately familiar, especially if like I'm upgrading an old system that they used to use a DMM and now they're going to use this new front panel, if you can throw one of those DMM looking gauges on there, it makes it really easy and really familiar. And, there's a reason that's what voltmeters look like. And there's a reason that, audio engineers really like that kind of VU meter. And so leaning into that familiarity can be a really great way. So we now have data and we've given it some context. So now we can take these kind of seemingly arbitrary numbers and actually have a little bit of information about it. 99 liters means it's just about full. 27 RPMs, healthy speed. I get my warm and fuzzy feeling knowing my engine's healthy. I know that we're on step 7. I know that means we're halfway, and that tells me a lot of information. Or I know that like, oh, that pressure drop because I knew the physical context. That gives us some information. All right. So now we've taken data, we've added context, and we have information. But we're not to a story yet. We're not to a narrative. So now we're going to take that information and add impact, and now we get our narrative. Impact is the so what of it. The engine's running at 24,000 RPM. It's normally at 27. You're in the red zone. So what? Do I abort the test? Do I throw away the engine? Do I need to, take things down for service? What's the actual impact of that? And so one of the ways that you can help convey the impact is just by being careful of how you control your user's attention. A lot of times engineers want all the data. And I've had engineers who have a UI that's just every square inch is covered with another indicator and another control. And I'll ask them like, during an operation, like what are you watching? Like, surely there's only a couple of key performance indicators, and they'll be like, I watch them all. I look at every single number. I have all that context in my head, and I can turn those 500 numbers. And if one thing goes wrong, I'll immediately know it. And it's like, I don't think so. So how do you control that attention? So, sizing to fit. So, this is a screen from a Tesla Model 3 where it doesn't have a speedometer. And so that big 65 in the top corner is your speedometer. And so that's kind of the most important number that you're going to monitor continuously. You'll also notice that there's no range context on that. And I think that's because speed, we all kind of have that context. And, when I'm thinking about speed, I'm thinking about it, plus or minus the speed limit. And so, this screenshot doesn't, but yeah, a lot of them will show the speed limit on there. So you have that context. There's a principle in UI called quiet dark. And that's that if everything's going well, everything should be kind of flat and quiet and dark. And you'll notice that the majority of this UI is just kind of grayscale. The few things it draws attention to, it's that blue steering wheel lets us know we're in self-driving mode. We have the button, the action that we're going to take to navigate on autopilot is big and bright and blue, and then our route is blue. But there's not a ton of colors, and so that means that when I'm just driving, I'm not having numbers wiggling or things that are taking my attention. So yeah, that's where that extra decimal you added to get the wiggle. You're like, okay, now everything's wiggling a little bit. And now I have a little bit of a seizure every time I look at it. A layered approach. So those engineers love to have every single piece of data on every single system, and you just can't focus on all of that. You're going to miss things. But sometimes that niche context is really important. Sometimes you do need to know the fifth temperature sensor on the motor and what it's doing. And so build that context in layers where, you start with that really high level executive view that just tells you, how things are going at a high level. And then slowly you can zoom in and maybe you click and it pops open a window, or maybe you open up a tab, or you have a nice panel slide in from the side that gives you that extra context on demand when you need it, but then hides it when you don't. And then color carefully. Working with, I've worked on a couple different projects that were related to NASA, and one of the NASA guidelines is, you shouldn't have nominal red in your UI. A lot of times if you throw down some default, temperature slider or something, you get that big red bar, and then it makes it that if you do have an error or a hazard or a caution, that it kind of fades into the background. And so you do have to be thoughtful with what do colors in my UI mean? What context does it give? And I'm going to say red is only used for hazardous things. Yellow is only used for caution things. And then I'm going to show voltages in purple and pressures in blue, and now I can use that color, but I'm going to keep them dull so they're kind of quiet and dark. They're not it's not a rainbow dayglow experience for my eyeballs. And then you do have to think about accessibility. Don't encode a lot of information into color and then forget that you have a colorblind operator. There are a lot of great tools that you can use where you can upload a screenshot into a tool, and it'll show you different types of color blindness, along with like what percent of people are affected by that. But yeah, if you have a big red-green that tells you, yes, this went perfectly well, or run and leave the room, make sure that color is not your only way to know that. Attention is good to control kind of what you're looking at, but in the end, the narrative is about what action you take next. If it passed, then I'm going to move it on and ship my product. If it failed, then I'm going to go do some more R&D or scrap that part. And so, in the end, it's about what action you're going to take. One important thing is not hiding forks. And what I mean by this is, let's say I have a nominal path, and 99% of tests, I just go through step 1 through 7, 1 through 7, 1 through 7. But every now and then, if this goes bad, you got to skip this step and go over here and do this, and you lose that context. And so when that does happen, your operator is caught off guard. They're used to hitting next, 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 and suddenly they click next, and I didn't actually mean to do that. I forgot that there was this branch. There was this hidden branch that only comes up every now and then. In space flight, a lot of times, if you're watching the broadcast, you'll hear them say at the beginning of a test, if at any point we need to abort, say abort, abort, abort on the comm system, and we'll all proceed to section 14.6. So now I've planted that seed that like one of the possible outcomes is that we're going to abort, and if we do abort, here's how we do that. Here's how you trigger it. You click this button, you say this thing, And then here's the section we're going to go to follow that. So, at the same time, you don't want to, if your system has a lot of forks, you don't want to overwhelm people. And so, you can hint at the forks or, show like, if error, move to step 7B. But yeah, don't hide the forks. Give your users a heads up. If there's an action, especially one that's time sensitive coming up, give them a little warning. Mature operators will get used to that and understand the cadence of, okay, I'm waiting for this 90-second test to finish, and then as soon as it's done, I'm going to swap the unit enter test and put in a new one. But, I get a prompt at the beginning that says, hey, this is going to happen after 90 seconds, and after 90 seconds, here's the action you're going to take, and now here's a counter that shows you that. And so I'm able to give my operators a heads up, and so they know exactly where they are sequentially, and they know what action they need to take, and then they can actually plan for that. And sometimes that's like, come back in 25 minutes, and it's like, all right, coffee break, and is this a sit and be patient and try to meditate for 6 seconds? Is this a coffee break, or is this a leave it overnight and we'll come back and check in the morning? Just-in-time info. This is actually a pretty easy one to do that I wish we all did more. If something weird happens with the motor, the first thing you need to do is pull up the motor data sheet. Where's the motor data sheet? It's in an email from March. It's on the Google Drive. No, it's in Box. Just Google for it. No, that's the wrong number. Build it into your application, put it in your source distribution, and put a link to it so that you can click it and you can pop it right open. Or better yet, if it's context used all the time, paste the data sheet onto your front panel. Put it right there, or put it just in time. And so if it's nominal information that you're going to use every time, bake it into your UI. If it's occasional information that may be really handy, especially if it's something that may be time sensitive, add that link. And so, when my test system explodes and I suddenly spilled chemicals everywhere, if I'm one click away from the safety data sheet, that makes the system safer, because now, this only happens once a year. And so, your operators might not know immediately what actions to take, but that can be really helpful. But yeah, have it pull up a mail to and email the safety team or send report. So that just-in-time info can be really great. Don't make your users hunt for it if you know where it is. And then, yeah, decode actions. In LabVIEW, especially with things like errors, we've all had that time where a user comes to you and says, what in the heck why is my GPIB mad at me? I don't even have a GPIB. And so you have to do a little work to decode that. Now, it's a lot of work to do that. Pick your top 3 errors, decode those, decode more as you go, and build a system that, 6 months from now, if my operators are constantly running into this new error, I'm going to, add a thing that says it in plain words. When I worked at NI and did phone support, we would often, I started doing GPIB phone support, and we would get a call from a customer and they'd say like, my GPIB device just won't show up. And the first question is always like, well, can you confirm that it's plugged in? And they're like, of course it's plugged in. I'm a competent engineer. How dare you question my wherewithal? They're like, okay, it's plugged in. I'm reading here that occasionally pins can be corroded on the connector. Can you go ahead and disconnect the connector and inspect all the pins and see if there's any corrosion? They're like, okay, fine. You'll hear them rooting around under the computer desk, and then they're like, oh, never mind. I figured out what it was. And so if you can decode that action, that rather than getting some obscure GPIB error, it says it's unplugged, then you can save a support call. You can, that could be a support call that, happens on a Friday afternoon and doesn't get addressed till a Tuesday, or it can be something that the user can resolve in 2 seconds, and this pops up and they know immediately what to do. All right, so now we've taken information and talked about ways to add impact. So we had that information from the previous slide that are kind of these qualitative, quantitative things. I have an idea of it, but what's the narrative? And so now just about full means like, okay, 2 more minutes. I have enough time to go grab a coffee. It's a little hot. It's kind of on the border. If it gets above this threshold, then we're going to flush liquid nitrogen through the system and cool it down. But no action now, but I know the action I would take, and I know the trigger that would trigger that action. Motor's healthy. This doesn't have an action immediately with it, but can be really valuable. that warm and fuzzy feeling we all get when our system is working can be really reassuring. And knowing that it's working perfectly, or knowing that it's not yet tripped your thresholds where it's going to start failing or throwing alerts, but like the trend is heading in the wrong direction. And so, even nominal configuration can be really helpful. This one was really slow. I know my action is I'm going to report this to R&D to go take a look at. Halfway done. I know we have 90 minutes. We're only halfway done. We were supposed to finish this a while. I can now tell my frantic boss, okay, it's going to be 90 minutes late, but we're going to have the test results, so it's on its way. But I can tell that narrative now. And then the pressure drop after filter. I'm going to go create a maintenance ticket so my technician can go swap that out. So data, we've talked about numeric, range, physical, sequential, and historical context, so that we can take those raw numbers and give them a quality so that anyone can look at that UI and immediately know things are going well. That's always the test, is like if you hold up a UI and someone looks at it, can they tell if things are going well? Now, a lot of times you're designing for operators who might be using this 8 hours a day every day, and so they learn that context. But if you can save them some brain cycles every single day, and turn what used to be like, I really watch this number during the test and make sure it never goes outside of this, and instead they can go get coffee and come back and look at a chart that has nice bounds of expected. You save them a bunch of brain cycles. They can now focus on other things. And those are the kind of things that operators won't necessarily ask for. If you say, like, if you designed your dream system, how would it work? They might not think about these things. You got to anchor your model with your operators, but they don't always know what they want. And so that's where a developer who's being thoughtful about the context and the impact can make it easy and intuitive, and eventually something that becomes boring and then automatable. All right, story time. Does anyone know what happened on March 28th, 79 in Harrisburg? We got a few. Okay, you guys know. Yeah. All right, here's a UI. I'm going to give everyone about 60 seconds to just take this in, since it's your first day as a nuclear operator. All right, who can tell me a story? Yeah, it might not be big enough. Sorry about that. Yeah, can y'all see those alerts at the bottom? So I can say, are we still generating power right now? How many megawatts are? Okay, we're only at 29. What's the total capacity? Is that really low or is that really high? Like, oh, that's barely there. Yeah. What's the reactor pressure? Reactor pressure is 2.4 kilo psi. What's it normally? Okay, normally it's in that green zone. Gotcha. Okay, normally it's 1,000. We're at 2. Okay, that sounds bad. Do we need to evacuate the county yet? Is the radiation bad enough that we need to evacuate? No, it's not. Yeah, so we know our evacuation threshold. We know the meaning of what that red line means. We know the context. And in this case, the actual backstory is that, of course, like any failure of this, there were lots and lots of sequential failures that happened, lots of poor maintenance, lots of bad decisions. But one of the ones is that the cooling loop slowed down, the reactor quenched itself, and it started to get too high of a pressure, and so they opened that PORV valve, the pilot operated relief valve. It went open and then never closed. And operators watched for 2 hours and didn't know what was going on as the water all started to boil off, and eventually the fuel was exposed to air and had a meltdown. A new operator came in with a little new context and a little fresh eyes and saw, hey, why is that valve? And then closed that block valve and then solved it. And the commission said if someone had realized that valve was stuck open, it would have been a minor inconvenience. And so, one little piece of valve feedback could have saved a lot of. So a couple of pitfalls just to mention. So it takes a lot of work to make a narrative UI, to get all that context, to get all that data. If I have thousands of channels and I have to figure out the nominal range on all of them, that can be a Herculean task. And so okay, maybe I don't do all 1,000. I'm going to pick the 5 most important ones. I'm going to do that. And so I a lot of times think of dev hours versus eyeball hours. I'm going to spend, if someone's going to be looking at this thing 8 hours a day, every day of the week, then like it probably justifies me spending a week on it myself. And if you spend a week on a UI, you can make something really nice. Now, don't spend a week on a UI that's only going to be used 5 times. And so you have to think about that. Dev hours versus eyeball hours. And eyeball hours is useful. Yeah, if it's a UI that's going to be literally open 24/7 in a test system, people are going to be using it, making decisions, taking actions based on it. It's worth optimizing. We're software engineers. We're not rocket scientists. We're not nuclear. Well, maybe some of you. We don't have all the context. And it takes a lot of work to go get that context from operators. And so if you can create a system where operators can do that themselves, where they can add the ranges themselves, where it's config driven, where, oh, actually that pump's, we got a new pump and we need to bump those ranges out. If that's not okay, I'll put in a ticket and maybe in the next release in 2 weeks we can get that in. If instead that's something they can do. And then yeah, more info is not always better. More context is not always better. You do have to tune it, build it in layers. So this is something we've been working on at JKI, where we want our operators to drive the UI. So we have a control system framework with UIs, and at any point, an operator can click that button in the red corner, and it'll open up Explorer to their VI and their INI. And this is actually a completely codeless UI. It's just controls on a panel. The VI doesn't even run, but an operator can change that. So actually, I want to swap those valves, or I want to change that context. They can do all of that in seconds, live reload it in their EXE. So yeah, so as you're thinking about data and information and narrative, one of the tests is the foot test. So if your operators are operating like this, you have data. If you can step back a little bit, you have information. And if you can put it up on a screen and someone from across the room can know it, an executive, when the governor comes into the nuclear reactor and wants to know what's going on, even that person can understand what's going on. It can add a lot. All right, so let's see. Hopefully, Laura has sent me some slides. Did we get any cool UIs? Let's see. Ooh, great. No, I want to download. All right, and we can go through these, or we can go through questions. So before we dive in here, does anyone have any questions or comments about context or impact?
In one of your earlier examples, you had a slide rule that was built on top of different color boxes. In one of our coding standards documents, we specifically don't have any controls or indicators overlap. As it was explained to me, LabVIEW doesn't like it for some reason. Is that way of thinking obsolete?
There are some redraw penalties if you have overlapping controls. And if you're worried about performance, and if you're right on the bleeding edge, that can be one of the things you can do to fix that. Most of the time, I'm not, hopefully not on the bleeding edge of my computer. So yeah, there is some penalty. I don't think it's in of itself significant. So I don't think it's a mandate that you can never overlap controls. And there are a lot of great times when it adds that. So yeah, it's just, I believe there is a cost, and I'm sure someone in here can probably tell me exactly what that cost is. Yeah, I've also been told not to do it, but generally it works out fine.
Yeah, so to that point, it's actually graphs that are the worst for having because you're redrawing stuff when things are on top of each other. But then the other comment I was just going to say generally about updating UIs is to decrease how often you update it. Like your process might be every 50 milliseconds, but you definitely don't want to update your UI, especially if you've got that wiggle going on. So
what rate do you guys use for UIs? 5 or 10? Five's good enough for most things.
Yes, thank you for all your great ideas. One thing I guess like a comment from my experience, which is almost entirely in a research environment, is keeping track of the ultimate user being which computer it's on. If I'm developing on a 28-inch monitor, but it's ultimately going to be used on a 13-inch laptop, I better have done my homework and moved it over to the 13-inch laptop and said, what does it look like?
Well, it's a good thing you went and sat behind the operator before you anchored your model before you got started. Because yeah, that's the exact kind of thing that might not show up in the spec sheet, that your customer might not communicate, but it's really important. Absolutely.
And a lot of the operators, even in the final use, they also have not taken that 13-inch laptop out into the sunlight.
Yep.
Where it's going to be used.
Yeah.
And we were all looking at it in the office.
Yeah.
Out in the sunlight, all of a sudden, that's when the customer shows up for the demo. Nobody can see it.
Yeah.
It looks like crap.
Yeah. You have to physically go occupy the space where it's going to be used. All right. We have like 2 minutes left. Okay. Another question.
To expand on his remarks, I think it's important to build trust with your operators.
How do you build trust with an operator?
Get them to believe that they won't get in trouble for pushing the big red button, that sort of thing. Tell me when there's a problem, and really reiterate, if things aren't working the way you want, it's my problem, not your problem.
Yeah.
And the other thing is not quite related is if there's a sticky note somewhere on a monitor that says, make sure you do X, that's a call for you, the programmer, to do something.
Yeah.
It's very important. I think it's.
Yeah, one of the ways you can build trust and relationship with your operators is by doing their little requests. So sometimes, even though it's not a high priority, and even though it's not a big impact, and even though you have a lot of other things, if you can go do that little thing and change that color or put that button on the other side, that little favor that you can do for your operator can build a lot of trust. And then when you need someone who can go give you all of the context on a pump motor ranges, they're more than happy to sit down and walk you through it. So yeah, that's an important thing to build that relationship. So yeah, we have a couple of UIs here. So do we think we have data, information, or narrative here? Can anyone tell me a story about this? I see a lot of red alarms, so that makes me think it's bad. I do like that we have a summary up top that says I have 6 alarms. But yeah, looking at that data, that sure is data. Those graphs are very, with that last one, the temp C, I can at least see one of these things is not like the other, and that can lead into a good story. Here's an interesting one so we had like a temperature range where you set a low and a high, but it's 2 separate knobs. And like, why don't you make that one slider with 2 knobs? And then I can see the lower one and the higher one and the relative positions of them. Because if the high is low and the low is high, maybe it doesn't work. Maybe my UI is smart enough to do that. But that's okay. Put those 2 numbers in context of each other. Then we have the one at the beginning. Okay, so it looks like this is like a time-based sequence that we're going to be setting certain values. Oh, interesting. We have a checkbox for like each different. Okay, I think I figured it out. So if a checkbox is there, we're going to set that channel to that value at that time. I do like that this tells the sequential story for each channel. And so if I want to say like, when are we turning the fan in grow box 3 on and off? I can visually follow that one column and know, yep, step 1, and not again until 48 seconds in. So I like that. Any other comments on this one? All right, that's about it for my time. I love talking UIs, and so if anyone would like to share their UIs, or I'd love to talk and love to learn more about how you give context and impact for your operators. Thank you.